Yeah, and we have just another minute before Peter Jackson comes on talking about Bokashi and Korean natural farming. So I just want to check in. I made you a co-host, Peter. And so, and I believe, and our team is back. David Algren is ready with your slideshow, I believe, or is getting ready with your slideshow.
I'm getting it queued up right now.
Yeah, we're pulling it up. So thank you for being here. I really appreciate it. And I think on our website, on our schedule, we have information for Peter, Cascadia Natural Farming. And I don't have Venmo or PayPal information for you, Peter. We like asking people to make a love offering of money if we can as an extra thanks. So if you have that information, I'd love to put it in there.
I don't actually have either of those things.
Okay.
But if they really want to, they could like send me something in the mail.
Okay. All right. Cool. And just thank you so much for the information you've been putting out there just through your website and Facebook and going to things like Global Earth Repair where I met you.
For sure.
I just, you are so generous with what you've learned, and happy to have you here. And with that note, go for it. And in general, we can have questions in the chat or at the end, unless you want to take time for that, and let us know how to support. And now I'll mute myself. Thank you.
Cool.
And Peter, I have a video queued up that was in our file. That's what I found.
Yeah, we'll start with that.
And here we go.
Here we are, the beautiful smoggy skies of Washington. And how do we help heal and fix our soils? How do we help heal and capture and store all this water and carbon instead of just infiltrating and evaporating? Well, here's one of the many arrows in the sort of regenerative agricultural quiver we are going to learn about right now, which is Bokashi, which is a specialty of nature farming from Japan and Korea, Thailand, Philippines. There's many variants. We're going to do a very stripped down, bare basics version of Bokashi, but a slight variant as well. And so I'm going to explain a little bit about what Bokashi is first. Bokashi is a Japanese term that means fermented organic matter. It is similar to compost, but in the modern era, we often do a lot of hot composting, and the idea is do a lot of turning and energy intensive labor because you want to kill any pathogens. Well, this is a much different approach. This is instead we're working with what's called facultative anaerobes, often many of which are probiotics. And so we're going to be doing basically a lacto-fermentation of oats. In many places in Asia, they will use rice bran, but I'm in North America. I would have to special order rice bran from the feed store. So here we're using oats. Oats is actually probably second best of the commercial brands in comparison to rice bran, because rice bran is best because the fat and oil content actually ends up being better food for all the fungi. But you can use wheat mill bran, you can use rolled oats, you can use newspaper. Literally, you can Bokashi newspaper. All you would have to do, though, is add some molasses. So that way, for all the carbon, you need some carbohydrates to really help kickstart the fermentation process. So when I discuss these things to Americans, I often feel there's a sort of cultural disconnect, because so many places throughout Asia, there is all this history of fermentation. So many places still don't necessarily have refrigeration. So there's this history of making rice wine. There's this history of making miso. There's this history of making ferments like tempeh. And so this falls definitely in that realm. And in quite a bit of ways, this is all going to be about wild fermentation today, because the cultures I'm going to be using are not what has helped popularize Bokashi, which is effective microorganisms. I'll explain this in a little bit, but some homemade indigenous microorganism cultures. So here I have a rice bran, or hard cooked rice that was buried in a basket in the forest for a week under some deciduous maple, and I grew a nice mold that looked very much like tempeh over the rice. And so I was able to basically capture an imprint of the forest microbiome. And so very similar to like a fecal gut transplant. We're trying to take the good microbes from an area that's less disturbed and not dysbiotic. And then this is how we can help heal the soils and heal the waters, because we're taking the OG microbes and we're going to put them in a place that's maybe been more disturbed, tilled recently, or it's dealing with erosion and compaction. And so this is a great way to do all this. So the history of this actually goes back hundreds, if not thousands of years. If we were to look at the first recorded writings in China about molding rice to make wine, it goes back to 400 BC. And so that's because if we look at then even further back in history, we have like the oldest beer would be, I would chew this up, I would chew up some grains, my saliva contains amylase, which is an enzyme, and that begins the breakdown of the starches and the sugars. And then, you know, still in place in the world, they're chewing up some corn, spitting it in a bucket, and making a brew called chicha in places like South America. So that's a brew going back probably tens of thousands of years. Then we start to get to the malting process, and people knew you could sprout the grains, which also secretes the amylase enzyme. But then at least 2,300 years old, we have in Asia the domestication of a mold called Aspergillus oryzae, also known as the koji mold. And so Aspergillus oryzae does the same thing as our saliva or the malting process, in which that it releases the amylase enzyme, and then that breaks apart the starches into more readily available sugars, which are then able to be more readily consumed because the microbes have small mouths. But they're able to do all these wonderful, you know, chain reactions through fermentation with enzymes. So you got two main pathways in the anaerobic world. You got a fermentative pathway, and you have a putrefactive pathway, which is more like rot. That's when you get those stinky odors. At the end of this, when I will end up with this, which is my finished Bokashi, this is about 10 days old and has a beautiful smell like sourdough bread or baking, or, you know, beer making. And that's similarly when you're capturing the rice culture, you want it to also be a very like sweet smelling culture. And so that is, you know, some of the history. Then we get in about like 400 years ago in Japan. There was some Chinese texts that were brought over in the shogunate era, and there was a guy, I'm not even going to try to pronounce his name, but he basically helped introduce this idea of going into fertile mountain valleys and capturing some of the, you know, moldy rice balls, or even just taking some of the soil itself and then bringing it back to the piles of agricultural wastes. And so you turn your waste into your resource. And so in every village in Asia for thousands of years, you have giant piles of like rice bran and stuff. A lot of places, maybe they're burning it, but in some places they know better. And so then, you know, we fast forward to maybe 1908, and there's this guy, Franklin Hiram King, who is the inventor of the modern silage silo design, and also the author of this book called Farmers of 40 Centuries. And in Farmers of 40 Centuries, there's a really interesting picture I had a little aha moment in with this winter, where it showed compost piles in China that were covered with a clay seal. My friend Steve Diver, he's also shown pictures on the internet of biodynamic farms in India doing the same thing, and they asked him if he could tell which of the compost piles had been applied the biodynamic amendments to, and he was able to see that the pile that had the most cracks was the most biologically active. So yeah, so this ancient sort of composting stuff, even Sir Albert Howard, he learned composting in India. So we see, like, actually, while Europeans like the Romans were composting, there was some sort of disconnect over their you know, next 2,000 years, where all of a sudden you get wars over bat guano in between, you know, the British and whoever else. You get lots of people just burning the stubble of the fields constantly, and so there wasn't this, like, that was what the thing about book Farmers of 40 Centuries was pointing out, was like, look at this, for 4,000 years the Asian population has been maintaining fertility in China, Japan, and Korea in very close proximity, you know, population density. And that was because just all the manure, all the waste were constantly being either like fermented. There's also pictures in farms before centuries of big pits full of water where they throw all the crop residues in, and then after a while dredge out the solids, mulch those, but then they'd also have like a strong liquid nutrient, you know, tea to top dress. So I think this is very ancient stuff is basically all I'm trying to say, that this has roots well before we get then into, say, 1969 or so, and we get Dr. Teruo Higa in Japan. He had been exposed to some chemicals in his research, and so he changed paths, and he went from the chemical agricultural perspective to the perspective that maybe we can work with microorganisms. So he was researching various blends of microorganisms. Pretty much all of them were probiotic, coming from the cultures of fermentation in Japan. And one time he was going on vacation, so he decided not to pour some microbes down the sink. He went and poured them outside. And when he came back from his vacation, he saw, wow, like there is so much going on. Like this grass looks so healthy. And so he went back to his notes and was like, what was I working on that day? And then over the next 20 years, there became to be what's known as effective microorganisms. At one point, it had over 89 species all mixed together, including Aspergillus oryzae, the koji rice wine fermenting mold. It had Rhizopus oligosporus, which is the tempeh mold. It has Bacillus subtilis in it still, which is the natto bacteria that makes, you know, natto all gooey and sticky, and is also a great ally to plants. And so here I have a bottle of EM1 manufactured by the Epigenetics company in America. EM doesn't distribute microbes, or the EM Research Organization doesn't distribute microbes from Japan. They try to sell a formula, license it, and then people worldwide can collect these same microbes because they're ubiquitous. But then some people say EM1 is just the IMO, indigenous microorganism of Okinawa. So, I mean, I bought in one bottle of EM1. I read lots of Dr. Higa's work. I take great inspiration from him. But I like to use the indigenous microorganisms because instead of being made in a lab and kept under stable temperatures, these sort of microbes have been dealing with temperature swings, ice ages. You know, they've never had a day off in their lives. So while I do appreciate all the knowledge, and I will explain a little bit about the EM consortia, I personally don't use EM myself. But here's the very beautiful thing about EM1 is we have like lactobacillus, such as Lactobacillus plantarum, fermentum. Those are found in your kimchis and your sauerkrauts. We got Lactobacillus casei, which is yogurt. We have Bacillus subtilis, like mentioned, Saccharomyces cerevisiae, which is our favorite. You know, it basically domesticated the human species to grow wheat for it because yeast took over our brains or something, and that's why it's a bunch of drunks on this planet. But yeah, Saccharomyces is a really good friend. You know, it also makes bread. And then we have Rhodopseudomonas palustris. Now that is really what you're buying the bottle of EM1 for, because all these sort of lactobacillus and the yeast, they're very ubiquitous. They're everywhere. The Rhodopseudomonas you'll find in stagnant waters, also freshly tilled soil. I believe they might be free floating in the oceans, or maybe that's another type of what we call purple non-sulfur bacteria. But the purple non-sulfur bacteria are very important because they have 4 different modes of metabolism. They can, you know, make sugars, they can fix nitrogen, and build carbon. And I can't remember, and I don't want to look at my notes, but yeah, if you look into the purple non-sulfur bacteria, there's really the core of what the EM1 is. But it is kind of interesting because the yeast and the lactobacillus like a very low pH, and then the Rhodopseudomonas likes a neutral pH and actually prefers feeding off of like rotting animals and stuff. So you find Rhodopseudomonas, for instance, in fermented fish paste, and supposedly that's part of the secret to Asian longevity is that they it's the fish sauce in the diet. But besides that, yeah, I personally I have here a homemade lactic acid bacteria culture, which is just wild. I have no idea what these species are, but I did this in the Korean natural farming style, where what you do is you rinse rice water or take the rice rinse water, and that's only sat with the rice for about 5 minutes. Let it sit out for 36 hours to maybe not really no more than 2 days. And then you pour that into milk. And because the rice water is collect the airborne bacteria locally and then fed all the lactose in the milk, it curdles the milk. You get a nice cheese curd you can feed to dogs, pigs, chickens, humans, and then you get a whey. In this case, I just added some sugar to help it from transport from being in a fridge and also activate and wake up the microbes. But in true Korean natural farming, you would add about 50% sugar to your finished whey or lactic acid bacteria serum, labs serum, because then the sugar, you feed so much sugar to this that it cannot, the microbes have no ability to digest it. It's similar to just like how jam making, once sugar content gets about 15%, usually no spoiled microbes can be present. And I explained how I did this, but what I'm going to do actually is the little Filipino variant we get from the godfather of organic farming in the Philippines, Gil Carindang, who also helped bring a lot of this to the West Coast. And while this is not like pure Korean natural farming, this is a nice hybrid technique because he calls this beneficial indigenous microorganisms. So what Gil will do is he'll take the IMO2 culture, which has been, captured and then stabilized with sugars, and then he pours about 2/3 of the lactic acid bacteria serum, labs. And so now I have another unique acronym, if they're not already overloaded, which is called BIM, Beneficial Indigenous Microorganisms. Like I said, this is a Filipino variant. This guy came over to Santa Cruz in, I believe, 2003, and also was out in Hawaii around 2009. So he really helped bring the indigenous microorganism concepts over to North America. And he studied in Japan with nature farmers who used EM, but he also learned in Korea with Master Cho, who is the father of natural farming in Korea, South Korea, that is. And so anywho, I got first that I'm gonna add some molasses and get the microbes even more stoked out. And then, because rice bran doesn't, behave quite the way that oats will, and these are just whole steam rolled oats, feed grade. I already have some that have been soaking. So I'll mix the oats that have already soaked in about 1.5 gallons of fresh water and 1/2 gallon of seawater, because seawater provides lots of minerals and other good beneficial microorganisms. And so I'm also going to add a little bit of flour, because the idea is that we're trying, if we're using a bran, the idea is that it can get squeezed but fall apart. Just like, it's like kind of like the ideal loamy soil. We're not trying to bake bread. We're not trying to make a dough. We just want to give our microbes food, because we got these shelf-stable cultures. And that is the thing about EM1 is, I want to finish one last little tangent before I forget. EM1, you cannot indefinitely extend your culture of EM1. Same with if you were to do this with the lactic acid bacteria serum. Eventually, you're going to lose that species diversity, and you'll get left with more lactic acid bacteria, alcohol sort of thing that then eventually degrades further along the lines into like a vinegar. And so EM1, you activate once and it's supposed to be stable for about 6 months. Lactic acid bacteria serum, it's cheap enough, you can just make it every so often yourself. I usually don't add the sugar. I just keep it in the fridge. Or if it's wintertime, I don't have to. But yeah, last summer I learned my lesson about keeping things in the fridge. The smell goes off. And that's the thing. Like I said, at the end, we want sourdough, sort of yeasty, beer brewing sort of smells. Like the finished Bokashi has a nice smell. And I could even ask an impartial observer, like, hey, Alexis, you want to smell this for your first time? And tell me, what's it smell like? All right.
Wow, like one from red.
Exactly. Okay. So get this going. It did soak up the water pretty good. Normally, I'll do this and then seal it in a 50-gallon barrel. Today, for the ease of transporting, I use a bag, but I will also seal this finished batch in a bag, but I'll also explain about aerobic bokashi, because there's variants that get more fungally dominated, such as IMO3, or even just, what's called aerobic bokashi. But yeah, we're going to do the lacto-fermented variety, which then ends up being more like silage. If you're familiar with the ensilaging process of turning nutrient, or basically foods that have no bioavailability, like cornstalk, stuff that would be burned, they've learned that if you ferment them in silage pits or silage silos, the breakdown happens of all the fibers, and then all of a sudden creatures like cows and pigs will eat all the silage. Oh wait, I don't want that bag. That's for another microbe tea if we have time. I want the flour bag, and this will give me a better idea of total moisture content, especially seeing as I'm going to be adding a little more liquid with the cultures here, the beneficial indigenous microorganism culture. And if you're doing this, like I said, you could, chop up newspaper. You can do it with sawdust. A lot of varieties will also include lots of animal manure, but those are the aerobic bokashi varieties. I've never heard about anaerobic bokashi where they incorporate the animal manure. But there's this variety is very suitable then for making specialized pig feeds, chicken feeds. It's similar, like a lot of people are getting into like fermenting for chickens and whatnot with just like a simple 24-hour soak. So there is ways to then use this. A lot of animal feeds, for even fish ponds, for instance. There was fish ponds in Thailand, and it was even just rice bran. It wasn't even actually it wasn't even inoculated rice bran. They were just using the rice bran as a food for shrimp or prawns or something. And what they discovered was that when this big like typhoon monsoon season happened, that everything, all the ponds that use rice bran had much cleaner water quality at the end. So now it's very often used that people are doing sort of Bacillus subtilis and purple non-sulfur bacteria, lactic acid bacteria inoculations of these rice brans a la bokashi, and then using them in all sorts of their fish rearings and other sort of aquaculture projects. Then there's this really interesting group called Aqua Mimicry Alliance or something, and they're one of the few people I've heard repeat this mantra. Because this is the mantra. This is like the secret behind why we're doing all this right now. Is that probiotics plus prebiotics equals symbiotics. Not symbiotic, but SYN, as in synergy. So prebiotics are these fibers, these things that we eat all sorts of fiber all the time, and we don't digest it. Our gut microbiome is digesting it and then feeding it to us in a more bioavailable form. So what we're doing is we're giving a source of prebiotics, which is the oats and the flour, to the probiotics, which is the lactic acid bacteria and the indigenous microorganisms from the forest. And so getting this pile mixed, making our symbiotic bokashi here, and we're about ready to add the microorganisms. I would have, if I had been doing wheat mill run, I would have just poured a whole bag of wheat mill run out on the table and not done the pre-soak, because it's 80% flour, 20% bran or something. It's just like the floor sweepings. So it's much easier to gauge the water content. We're getting pretty good though. And it's pretty moist, but I will add maybe half this jar. And a lot of these oats will continue soaking up moisture, seeing as it was half pre-soaked and half not soaked. But get pretty even. And a lot of moisture will stay on this tarp that didn't saturate. So I think I'll be left, ideally you're going for somewhere between 40 to 60% water content in these sort of mixtures. In Korean natural farming, for the IMO3 process, you would be doing this on a forest floor, because then you would be inviting extra diversity for it. And they say only go for, I believe, 60% water content. And then for the EM1 users in the EM1 users manual, which is called the APNAN manual, or Asia Pacific Natural Agriculture Network manual. I have a copy I'll show in a second, but they're wanting to keep the species mostly related to EM. So when they're doing an aerobic Bokashi pile, they would be doing it on a concrete floor. But then at the end, if this were to be an aerobic Bokashi pile, because the first step is the same, I would be covering it with a sack like this, and then monitoring the temperature and making sure it doesn't get above 120 degrees, stirring it as often as needed over the course of about a week, and then you're left with just huge fungal chunks. That aerobic Bokashi, such as IMO3 or done in the EM style, they will be they'll be more fungally dominated, because it's not quite like the silaging process. But when you anaerobically seal it in a bag, that is when you have something much more similar to silage, from something people in the West are a little more familiar with. So I'm gonna fill this up and seal it, and then maybe talk a little bit about where the term nature farming comes from, or maybe I can talk and do it at the same time. So there was this guy, and he was part of a Shinto movement, and it was called the Umoto movement. And some branches ended up becoming like Reiki. One of the guys ended up started Aikido, and then you have Mokichi Okada. And Mokichi Okada, he is the coiner of the term natural farming. Well before Masanobu Fukuoka, there was this thing called the Church of World Messianity, which was kind of Mokichi Okada's cult. But he was a true visionary, and he was seeing how chemical agriculture was not doing anything beneficial to people. It's not economically nourishing, it's not spiritually nourishing, it's not physically nourishing. And so he knew we had to stop. He didn't exactly maybe know how, but he knew we had to just stop and just, decide to take a lead from nature. And so he was the advocate of no fertilizers, no chemicals whatsoever, just compost. And then he died in the early 1950s. During the last 8 months or so of his life, he actually had some correspondence with Rodale. And I know some people don't like that guy because of what he did with, not focusing on the minerals and just focusing on the compost. But, whatever aside, then you have about 30 some years later, the intersection happened where one of Dr. Higa's students, the guy who came up with EM1, he happened to have, so Dr. Higa had this student, and the student happened to be a member of what was called Kyusei nature farming, which was one of the offshoots of Mokichi Okada's associations. And so the people who are already practicing nature farming, but it was being kind of hit or miss, they got introduced to the stable formula that could be replicated, which is the effective microorganisms. And so then that's how, by the late 1980s, you had organizations forming, such as the Asia Pacific Natural Agriculture Network. They had their first conference in 1989, and I was like 1 year old. But then, you know, now we have the EM Research Organization as well. There's an International Nature Farming Research Center in South Korea. There's been various nature farming organizations. Now in the modern era, you know, you have, for instance, my friend helped put out this book last year, which is called Natural Farming by the SARM Society, whose motto is heal the soil, heal the people, help the poor. And one of the 5 authors is Ray Yoon. And Ray Yoon has helped spread a lot of Korean natural farming into English. And so, whoops, getting it kind of dirty though. So, anywho, yeah, in the modern era, I am probably most closely aligned with SARM in terms of the fact that they are the least dogmatic of all the organizations. There's a lot more openness and willingness to just use what works and blend styles instead of focusing on sort of this dogmatic approach of having to go back and consult the guru and then whatever. Because in the modern era, if you have thousands of farmers all able to use the internet and talk from all these different biomes and climates about what's working and what, you know, is like full of cross-pollination possibilities in terms of spreading different places, and then what might be more site-specific. So I like the SARM Natural Farming Group. I'd recommend their book. You can find it on their website, which is sarm.guru. So I mean, for all the guru bashing, their website is sarm.guru. Anywho, so yeah, I'm gonna fill up this bag, and then I'm gonna put it in another bag to really make sure I get a good air seal, and it'll help with transport. My own organization, non-organization, exists in the form of a website and Facebook page, which is Cascadian Natural Farming. And so I did get introduced to the concept of nature farming and do nothing farming first, Fukuoka. Though I did first hear about EM back in 2008. IMO, I didn't start practicing until 2015, but it's all, and a lot of it does feel just like common sense, like, oh, like these aha moments when I mention this sort of fecal gut transplant concept to people, and then an old family friend tells me, oh yeah, the old timer said go get some huckleberry soil and then spread it around your blueberries, and your blueberries will have less diseases, because that's the thing, they're both in that same sort of Vaccinium family. So you can even get to where you're doing like species specific sort of, if I were growing a lot of carrots, I would perhaps might want some microbes from Queen Anne's lace. And so you can both go for the diversity approach of collecting microbes from many different locations and blending them together. And then you can also go for, maybe I want to help this specific crop out with certain things that might be a bit more transferable. Because that's the thing, actually at the end of the day, the plant chooses its friend. You know, we can give them this option to have this all-you-can-eat buffet, and maybe our microbes are strong and some might survive in the soil, but odds are, at the very least, it's a catalyst, and it's like planting seeds in a way that we're putting these microbes in a place that needs them, and then whether they just get eaten by the native fungi and bacteria and then just at least kickstart the cycle, or whether they might establish some dominance and at least battle off some fusarium or other sort of pathogens, we do end up with a pretty good blend of things. So anyway, so while I'm talking, I'm going to fill you in on history. So we have Mokichi Okada, and then of course the most popular of natural farmers in the West is Masanobu Fukuoka, author of the One Straw Revolution, and also The Natural Way of Farming, and was a big advocate for no-till agriculture and trying to reverse the spreads of deserts. He finally has had one of his ideas be realized with the Thailand government was dropping seeds out of planes as a reforestation project. So that is one real beautiful thing that he might not have seen in his lifetime, but at least did happen. So Fukuoka only died about 2009. And of course, you know, if you were to go on YouTube, you can find all sorts of stuff from Master Cho's students. That is one of the more dogmatic things. Korean natural farming definitely has a system that works, but a lot of people are probably like me, where they might not necessarily want to make everything. And so while I do recommend going into that as deep as you can, also don't be afraid to realize that, you know, Fukuoka didn't do much besides mulch and some ducks, and he had an incredibly fertile system going on, but it did take him about 10-20 years to establish, versus if you're using things like Bokashi, you can help the population of everything in your local ecosystem get a much faster start. And so while I'm here, and before I put the last of it in the bag, let's check the time. Okay, I go 7 more minutes. So I'm gonna just give a little demonstration here at the end. So bring this up to the camera. So here at the top of this is some beautiful soil from an old growth forest right here on Orcas Island. Just beautiful humus, well decomposed. I dug under the duff layer to get this right at the roots. Nice aggregation. Water would be able to infiltrate but also be stored in the soil very well. And I'm gonna dump that out. Make some room. Dump that out, show you what's underneath it, which is some really clay heavy soil. This is the soil I've been working with on Fidalgo Island, which is, you know, throw this against a wall and it just would stick. And then here's what my soil's turned into after years of seaweed and mulching, and also, you know, lots of compost in the early days. I don't compost much these days because I tend to just mulch. But here's a root ball from last year, still totally just being held together, even though the roots are all dead, you know. Just lots of, you know, little bits of broken down shell, and this is a beautiful soil. You know, it will squeeze together like chocolate cake and then still crumble. So it's a nice sort of like clay, silt, loam sort of thing going on. And one thing I can do with these clay heavy soils is, this is something that came from the EM Research Organization. Starting about 2001 to 2005, there was the cleanup of the Seto Inland Sea. The Seto Inland Sea in Japan was so polluted, there was barely any fish. The shellfish were dying, the seaweed were pretty much gone. So over about 5 years, they threw 1 million mud balls, EM mud balls, into the waters. So to make a mud ball, you take actually I'll use the finished Bokashi for this. So take some finished Bokashi, and you can use, I've done up to 50% ratios, but you can use about 1 to 10 as well. The idea is that then you're embedding these, you know, inoculated prebiotic bran fiber substances into a matrix of this clay soil, and then you can let this mud ball dry out and harden for about 2 weeks. And so over 5 years, they threw 1 million mud balls into all these estuaries and streams in Japan. There's still places where they do weekly dumping of like 5 to 50,000 gallons of liquid EM culture weekly, because it'll be like a river, but there's a laundry detergent factory upriver. So it's a Band-Aid. I mean, I will say, first and foremost, the EM mud ball is a Band-Aid. It only lasts about 6 months, unless, of course, you're stopping the pollution upriver. You're not going to be able to be like Wendell Berry and do unto those downstream as you would have them do unto you. But this is one thing you can do to help those downstream. And so the whole Bokashi making is probably my favorite aspect of it actually is the mud balls, because I've made a couple thousand of these and thrown them into all the local lakes on my home of Fidalgo Island. And then I've also started throwing them into the Skagit River. But last year I ran out of time and energy to make the mud balls. So I was working with filling like an old coffee bag up with about 20-30 pounds of bokashi, and then some heavily fungally dominated wood chips, and then still some clay heavy soil, and then just let the bag sit for a couple days, and then just chucked them into the river. And I threw a couple 100 pounds of that mixture into the river. But that river has the lowest dissolved oxygen content of anyone that enters the Puget Sound in Washington. So we need probably, you know, thousands, maybe 1 million pounds to really bioremediate all the pesticide runoff and keep it so there's not just these sort of algal blooms off the phosphorus and nitrogen that then create this low oxygen content dead zone, basically. So that is the Bokashi mud ball. Real simple to make. Great thing to do with school children. In 2008 or 2009, they did 1.8 million of these in Malaysia, outside of Penang, and they called that 1 million prayers to Mother Earth. And then the Philippines one-upped them again, and in 2015 in the Philippines, they got all the school children involved and made 5 million Bokashi mud balls and threw them onto all the waterways, and also tried to clean up as much plastic, you know, using like nets and scoop stuff, and really try to just do a great bioremediation project. And so when I find scientific studies that were like, oh, the mud balls don't work, usually those are people that are doing it in, you know, a very scientific way. They're going to do it with like, here's a sample of dirty water and here's a sample of clean water in a very small thing, and then like drop one mud ball. That is not necessarily representative of how it might function in an actual dynamic ecosystem. Because if you look at like EMRO, the EM research organization out of Japan, they have tons of documentation of like over like 6 to 10 months, literal feet of sludge being eaten out of sewage canals, and they have the Sado Inland Sea, for instance. I mean, I don't think the Philippines would have thrown 5 million of these in the water if they hadn't been seeing it work in these earlier countries. So there you have it, folks. There is a little demonstration on bokashi making. And maybe as one final little 2 minutes, I'm going to show you the very simplest of all the microbrews, which in that green book I showed from SARM, we call it Starch Bubble Tea. So Starch Bubble Tea, we're going to use these very beautiful old growth microbes I collected. Well, I do like to use maple. I didn't see a big maple that like jumped out at me, and this like grandma of the forest was like, oh wow, here, like, you know, I'm the biggest tree you're gonna see today. And I was like, yes, I know, I love you. And so here we're going. We're taking these beautiful old growth forest microbes, we're gonna throw them into the water, and we're going to add some food to them, which will be some oats I got not at the feed store, just the human food store. Sometimes I'll weight the sock with a rock. In this case, I think the soil will be so thirsty for water, it float too much. The rock just helps it sink. The stick keeps it from sinking too far. And then what I have done, just throw this all in without the socks, but the sock gives you a better idea. It keeps the bubbles, instead of you just having a floating mat, you can't really see the microbial activity. This will give you an idea of the activity, because the socks keep the microbes a little more contained, but you see all these bubbles forming around, and then it will start to circulate. And then about, in this temperature, probably 2 days, I would apply it, dilute it 10 times and apply it. If it was winter time, you know, you do it in the garage. Microbes breeding generally, any temperature above 65 degrees is going to be better. In some places, if it's 80, 90 degrees, this would be done in probably less than a day. So here's my final ingredient for the day, is just some regular human grade rolled oats. So I'm basically making like an oat milk forest beer, AKA Starch Bubble Tea. Yeah. Can be some squirrels that get to eat some tasty things today. Okay, that's probably enough. I normally do 50-gallon barrel. Same 50-gallon barrel I do my starch bubble tea, and I also do my bokashi fermentation in. You can also use boiled potato. That's why it's called starch bubble tea, because literally you can use almost anything. I found that squash didn't make very much good bubbles, but like lots of other basic starches did wonderful. So yeah, and then as my friend says, the microbes have small mouths. So it helps whether it's boiled potato or oats that you really squish it up. So it just makes it that much more bioavailable. And so there you have it, folks. We made one of the more slightly complex natural farming methods, but we also made one of the very simplest. And again, the idea is that you can just get the microbes from the healthy areas, and then they can, from there, be transplanted. And so just to give you an example of some naturally farmed produce, here is some beautiful apples. So these came from my own home orchard. I don't know the name of this red apple, but it's a beautiful red flesh apple. This is not red delicious. It tastes awesome, actually. And then heirloom Gravenstein. And I make lots of cider out of this. And then because of the fact that there's the whole, like, I'm using my yeast from the cider and pouring it back out in my orchard, using it in my bokashi, using it in my fermentation of other fertilizers, I end up then, there's this great native yeast population on the apples. So then I just do all wild fermentation. And so one last little bit, now that my hands are clean. So we got this book, Natural Farming, sarm.guru is the place to get this. It has 5 different authors. We have Luz Pilago from the Philippines. We have Richard Noonan from Australia. Pastor Lee from South Korea is passed on, but his work continues. And then also Eric Weinert from Hawaii and Ray Yoon, also of South Korea. And in the second edition, I wrote a chapter that will include Bokashi mud balls for bioremediation water rays. Then this is all about Korean natural farming. You can get this off of naturalfarminghawaii.net. This comes from Eric Weinert, and I'll show you a good picture of what an IMO collection, because IMO is the backbone of Korean natural farming. It's 80% of what it is. It's just if you get the soil right, you don't have to do much from there. Okay, here's pictures. So there we have microbes that went awry. You know, too much diversity, possible pathogens, probably had a stink, too many colors. This one's a little better, but then this perfect one here, it looks like tempeh. You know, you got this beautiful sort of fuzzy mold, same sort of thing you see in brewing rice wine or this soybean fermentation, and literally meaty, and it wouldn't fall apart. It'd be like a brick of mycelium. And then that's when you mix it with sugar and you get what's called IMO2. Of course, I should probably mention wild fermentation, because that's a good intro for people who are afraid of microbes to learn that you can find them from everywhere and make all sorts of tasty things. Mycelium running, Paul Stamets does show in this book actually mycelial transplants, and this is very similar to grain spawn and mycology, a lot of what we're doing. And then if you go to my own website, cascadiannaturalfarming.org, you can find both this one, which a lot of people say is too inaccurate. You know, you should go and buy the newer manuals, but this one is free, and it's been around for about 9 years, published by the Chose Global Natural Farming India. And I like those folks for at least getting this knowledge out there, even if some of the recipes might be changing in this era. And then specifically, if you ever use EM1, you should read the EM1 User's Manual put together by the Asia Pacific Natural Agriculture Network, because this is just all about Bokashi, EM1, and agriculture. And so that is called the APNAN Manual, Asia Pacific Natural Agriculture Network. There you have it.
All right, let's try to get my own video going here.
Yay, Peter. It's fantastic. Good job. I love it.
All right, thanks. Any questions?
I did, but I'm going to let everybody else go first.
Because yeah, I mean, I could fill in some gaps on all sorts of things that I didn't really quite get into, but I could also just take some questions in half an hour, would probably go by pretty fast, or however long we got, 20.
I meant to write those books down as I intended to. I kind of started getting the titles, but if
I can share. Okay, I'll share some of these books again.
you do that, I'll write them down in the chat. Thank you.
So here is a book that came out last October called Natural Farming, just natural farming. No, need for a national title to the natural farming. This is just like, get this out. It's not KNF. It's not Japanese natural farming. It's a collaborative effort to make this book. Anyway, you can get it from a website, www.sarm.guru. So SARM, SARM.guru. Let's see. There is also, I got these actually just in the mail the other day because I think Master Cho gets like $5 or something, and I've been learning so much of the Korean natural farming. So you can get these two books from the Cho's Global Natural Farming Hawaii website, CGNF Hawaii, and it's a little expensive, but whatever. It's nice to have books. Dr. Hegel wrote a really cool book. It's not published anymore, but it's called An Earth-Saving Revolution. Came out in like the 90s. I guess actually when he wrote A New Earth-Saving Revolution in like 2011, the Japanese government was censoring him because of what he was saying about the antioxidant powers of these microbes. So, I mean, this stuff is like a challenge to like big ag in a lot of ways, like just help people do everything without spending money on chemicals. There's also just if you want to see where like nature farming is taking off in the biggest way worldwide, it's in India right now, and it's called zero budget natural farming, or Subhesh Palekar spiritual farming. He's renamed it. First it was zero budget natural farming. You can still find all the information if you type in that. But then, Subhesh Palekar, the founder of that, he's got like a whole state in India with like 20 million farmers or something switching in the next 2 years over to this. And the suicide rate has been going down where farmers embrace zero budget natural farming, or Subhesh Palekar spiritual farming. Then I showed this book, which this guy's website was why I kind of there used to be a few other, like there's a Thai natural farming website, there was a Filipino natural farming website, but then those aren't online anymore. But this guy still has naturalfarminghawaii.net, and you can get this little Korean natural farming pamphlet from him. He used to be part of the Cho's Global Natural Farming. He's got his own thing now, but he's the admin for the Korean Natural Farming group on Facebook. And then this was where I first was learning about Korean natural farming. It's on my website. It's also many other places, but it was put out by some folks in India. The folks in Hawaii say don't use this manual called Cho's Global Natural Farming because of the inaccuracies on like 3 recipes. But I mean, it gives you a really good general picture of how this stuff works, and then maybe watch some people's YouTube videos that are supposedly teaching more right stuff, but then a lot of the teachers disagree on exact ratios and recipes. So it's like, really at the end of the day, I don't really give a fuck, like, about a lot of the sort of stuff. Just find what works. It's more this is not science in a lot of ways. This is more like being a good chef. And so there's a lot of intuitive things, like, just it takes a little while to learn, but once you get into it, it's like, it all makes sense. It's, I don't know. But then,
I liked what you said. I tried to write what I remembered of it in the chat. I think it was from the GERC Global Earth Repair video you made, that humans have been informed by their sense of scent for so long, it's ingrained in our cells, so we can trust it. So you call your intuition, right?
Totally. No, I mean, this thing, like, even just touching these ferments, you get really high, like literally. Like, this is one thing I didn't touch upon, but one of my favorite aspects of this is called psychobiotics, which is the fact that just as there's all these secondary metabolites being exchanged with the microbes at the roots, and the sugars being fed from the plants via root exudates, you know, they create all this interchange, like network of trade. In our guts is the same thing happening. So all we're making, you know, only about half of our own serotonin, half of our dopamine, half of our gamma-butyric acid. So that's why when you get a healthy functioning microbiome, the microbes reward you. They're like, oh, hey, we're happy here, so we're going to make you happy too, just like they're doing with the plants. You know, John Kemp says it's like 40% of total photosynthesis is all about sending root exudates into the ground. And so, yeah, in the whole like psychobiotic therapeutic aspect of like eating kimchi, it's like we're finding like all the countries where it's like Bulgaria to like South Korea, where they eat lots of ferments, like their death rates of this pandemic is like nothing. They're having no problem at all because the population is just generally healthier. It's like Americans are just all obese and disgusting to me, really. It's disgusting what Americans put into their bodies. And yeah, I'm not even gonna go into that, or I'll just say some probably hateful thing. But anyway, here's another manual, which is the APNAN manual. I mentioned this. It's also on my website, Asia Pacific Natural Agriculture Network.
I wrote that one down.
Okay, it's the EM User's Manual. So if you ever buy a bottle of EM1, there's no point not to read that. And then even if you do follow Korean natural farming, it makes way more sense once you understand like how these Japanese natural farmers are doing, because their cultures are all so interrelated for so long, and they have their sort of cultural battles of superiority. So, you know, they do a lot of these same things in both countries. You know, there's remarketing of EM in a bunch of different countries and just calling it a different name, but the same sort of formulas. And then just all the variants, like where, I don't know, like people will bathe in Bokashi, and in Japan they call it an enzyme bath. And then in like, you know, Korea, they're also doing the same thing with the IMO, with rice bran, you know, so it's different. Right. It's slight variations in microorganisms, but when they're doing these aerobic piles, they heat up, and you're trying to keep them below 120 degrees Fahrenheit. And so when people are laying in this, it's like a probiotic sauna. I actually haven't done this myself, but I mean, I'm just, I don't know. Hasn't really, I don't feel like I'm needing to like heal myself too much right now. So I haven't.
Can you hold up the title to that last one, because I missed it? And then there's a question from the chat. If you could give us a summary of your own place and what your schedule is like to incorporate this. Okay, thank you. Natural.
I wrote down APNAN manual already. That was the last one.
So what do you mean about the schedule?
Oh, there was a question. And when Julie started talking, I missed writing the end of that title, but did you get it in the chat?
Yeah, there's
it's in the chat. Yeah, it's in the chat. And the question was, can you give us a summary of your own place and what's your schedule like with using these techniques?
Okay. So a lot of these aerobic Bokashi piles would often incorporate animal manure. What I made is a more simplified, broken, stripped down version. And so that is just pretty bare bones, but I would still be able to apply that to landscapes at about 1,000 pounds per acre if I was really trying to restore fertility. And you could do that for 2 or 3 years, then you wouldn't need to do it so much. But right now, I've been using it as sheep feed because they're just loving it. I mean, so Bokashi is often being fed to like chickens. It's used in sort of like aquacultural setups. It's used in helping create odorless pig bedding. So there's like this whole deep litter system that comes out of Korea and Japan and Thailand and stuff. And while they are making basically like silages out of things like banana stalks and doing fermentation, lacto-fermentation, sealed to make the feeds, they're also then sprinkling probiotic sort of amendments like Bokashi over the animal bedding and have a really like deep litter. So then it creates this whole odorless pig pen rearing system, and that's very, very popular. If you happen to want to learn about that, there's a whole website called naturalpigfarming.com, I think it is. But yeah, it also probably YouTube or just other sources. Yeah, if you type in natural pig farming, or indigenous microorganisms, pig farming, effective microorganisms, pig farming, you can find lots of stuff about that.
When you're done here, maybe you could put into the chat, if you have it written up. It would be awesome to actually kind of like, what do you do once a week? What do you do once a month? That kind of a schedule would be really cool.
So I actually have applied it probably a couple times this year, but there is no weekly schedule. It's just like sometimes I feel like things, I'm doing lots of mulching all the time. And so I will try to kind of time it. Like if I'm going to go wheelbarrow loads of wood chips around for fruit trees, I will go try to get the Bokashi down first and then apply, because that's the thing. You always want to cover, okay, this is it. You can simplify all the good farming with this little phrase. Microbes plus mulch plus minerals equals magic. So the minerals, of course, you can top dress. They're not biologically active, doesn't matter. But the microbes don't like the sunshine, So this is where, when you're doing any sort of Bokashi application, I really wouldn't recommend it too much in small pots, because it can kind of tend to acidify the soil a little bit. So you try to use 10-gallon pots or higher when you're doing applications of Bokashi. But basically, yeah, the microbes don't like the sun. And so anytime you're doing some sort of Bokashi application, you want to cover it with a straw mulch or wood chips or something. And then that's where you see the fungal blooms happen once it's kind of, I like to call these like a fractal seed crystal, basically. Like you're just going to try to just change everything with just like, it's like planting a microbe seed. And so you can really only see the good stuff happen when you're doing mulching. So you cannot separate Bokashi from a mulch system.
Can we look at or talk to Sylvan? She's had her hand up for quite a bit.
Okay, what was the question?
I have a question about the waterways stuff that you were doing. Since you're in the same state that I'm in, maybe is that you're basically just throwing dirt into a river, so it seems like it wouldn't be illegal, but are you doing this like as a guerrilla ecological action? Are there any regulations that would prevent you from doing this? Because this sounds like something I want to just go do.
I'm using the indigenous microorganisms, so it's not like I'm actually like importing things. Like for instance, when the Exxon Valdez spill happened, there is a great company that had oil-eating bacteria that could have totally just done a huge cleanup, but instead they were all like, oh, we don't want to import foreign microorganisms. So EM1 and all their related information to this is like, works for some people to see like, oh, here's replicable studies, but because I'm doing guerrilla bioremediation, and I only use IMOs myself, I don't ever buy microbes. Like, I feel like I'm not doing anything but like just putting stuff back that was already there, especially in like started this because of a local lake got covered in milfoil and algae. So their response was like a bunch of like aluminum and fluoride heavy water treatment, like chemicals. So like literally like toxic death bomb the lake. Everything was dead basically. So I just started like going and reseeding biology, even though maybe it's not that much, I feel at least it's a good idea, And in one lake I did totally see, like in this more boggier lake, like the sludge layer was starting to be eaten, just like, is reported in all these other places. But so last year I was in contact with this lady who's a consultant with Tulalip tribe, and I passed on a bunch of information, and it seemed like there was almost maybe going to be like a water quality, like septic, like treatment plant, like study they were gonna work on. But then I guess funding was really hard to come in the Trump administration for like environmental bioremediation projects. So yeah, nothing ever really came of that I heard about. But I did pass these ideas on. I think I've tried to pass it on to Port of Anacortes, City of Anacortes. This lady who's a state senator now. Like I passed it, and when I was talking to this consultant last year, she passed the information I was sending her on to like Department of Ecology and City of Everett, Tulalip tribe. Like I've tried to get this information out to like anytime I run into someone working with the tribes on like, like river, like restorations and stuff. I give up. I'm kind of a misanthrope, and I hate bureaucracy. So.
But there's no regulations against it.
I don't care if there is.
Well, I mean, I'm just thinking.
You're going to have to
it'd be cool to
research
start
that
a project.
yourself. I'm using indigenous microorganisms, so I'm not actually importing any foreign thing into any ecosystems.
Yeah, there aren't any regulations that I'm aware of as far as moving dirt from one place to another within an ecosystem. He's not polluting anything. And I just want to interject that I think with your close relationship with microbes, a lot of our gut is what is actually our intuition and motivates us. So as far as your schedule goes, if you just kind of listen to what you think you're supposed to do, you'll be creating things and applying them to your soil as you should. And
also just try to, I mean, it's all about using your materials. We're not supposed to be going and buying rice bran necessarily in North America, but if you understand the sort of Bokashi composting technique can be done with absolutely anything. So it does become very seasonal and timed, it's just when you have those agricultural materials, similar for when you're making fermented plant extracts or fermented plant juices, it's when things are in season. So yeah, while you can kind of build up your bulk of natural farming amendments and try to make a schedule for yourself, and people definitely do have schedules, you just really got to do it when you have it, or when your resources allow it, if you do need to go buy off-site inputs. But the whole idea of nature farming is that we are trying not to import anything, and it's very biodynamics. The farm is a living organism. So I get lots of seaweed off the beaches and stuff, rock dust locally available. But yeah, the idea is just use what you have when you have it, and keep doing what works.
Peter, when
Oh, sorry, Julie, I accidentally hit the wrong button.
sorry, I was waiting. Peter, right now we've got leaves are about to be available. In the summer we had a meadow of grass mowings we applied everything to, all our microbes, but right now there's leaves, and the thing I'm wondering, or going to be leaves, with the windstorms, we definitely could start harvesting leaves. What I've heard is that it's better to chop them up by mowing over them, and I don't do that. So what do you think about using dried leaves as they are?
Oh yeah, leaf mold, if you just left a huge pile of leaves and create leaf mold in 2 years, that's one of the best sort of microbial inoculants too.
Right, but I mean yeah, I know it would do it on its own, but I want to continue to make Bokashi in all seasons. So could I just use whole leaves?
And there's also a question in the chat about using charcoal.
Right.
Yeah, I just answered that. Totally. Bokashi biochar, I've done that several times the last 2 years. Yeah, it's okay. What we're doing is we're trying. Why Bokashi is better than a compost tea, I would say, is because it's a microbe hotel. It's you're not just drenching a liquid on the ground, and who knows what's actually happening to it. When you have Bokashi as a solid amendment, you can literally see that action of those fungus, eating the lactic acid bacteria or whatever, all the things happening. And so biochar in a very similar way is a microbe hotel. And so if you use Bokashi in the stage of making it with biochar, you get a biochar Bokashi, you charge the biochar simultaneously with microbes and some ions at the same time. So it's great to incorporate biochar into Bokashi. Yep.
Hi, this is Christy, Northwest Washington, Raymond. And I have all this wonderful lobster mushroom that I'm drying, the stuff that I cut off. What did you say to do? Soak that with a little oats and I have a good start?
I didn't talk about lobster mushrooms. You can do fungal transplants where you could dig up some mycelium, and I've done that with wine cap mushrooms, is dig up some mycelium and mix it into oats and rice bran, and then spread that mycelium around once it propagated. But I mean, there is one sort of idea where if you took a bunch of really hard woody mushrooms and you soaked them in water with a little bit of add a little bit of some sugars and some microbes, you can create an extract of chitin. And so when you water in a fungal extract of chitin, or similar to top dressing insect frass or whatever, when plants sense fungal or insect chitin, even if it's dead, it stimulates their immune system. So that's one thing that I know of, but I've never actually done like mixing mushrooms into the oats. You know, I've mixed mycelium into the oats, but that's different.
So the chitin you would get from shrimp shell, clam shell, how would you get the chitin?
Soaking it in water.
What are you soaking?
Mushrooms.
Mushroom.
Like woody mushrooms, like woody hard mushrooms you can soak in water, and then you can make like a chitin extract.
Okay. Thanks.
Yep.
So I know you touched on this about the biochar, but I didn't quite understand the process of using Bokashi and biochar. Do you
So I would mix
mix it in?
biochar with the oats, and then when I do the fermentation for 2 weeks, that charges the biochar, or charges the charcoal and turns it into biochar.
Thank you.
So just like people put in compost teas or pea or, you know, any number of things. I put a lot of charcoal in my compost too, because I just do a stat.
We're currently having it in buckets and we're peeing on it, but I want to know the next step to really make it good.
Oh, nice.
Thank you.
Yep, for sure. So someone asked about tap water killing off microbes. There's a really good study that came out of Purdue University where they showed petri dishes of compost tea brewed using tap water with chlorine and then unchlorinated water to brew the compost tea. And there was like night and day difference, like full colonization of the petri dish versus a very little colonization of the petri dish. So Dr. Higa says whenever you're doing the extension of the EM culture or you making bokashi, that you would always use as clean of water as possible. And if you don't have access to that, use charcoal or a sort of EM embedded ceramic to filter the water through. Any other questions?
To translate what you told Marley just now, because it wasn't necessarily, we didn't all get it. Is it mixing the biochar with oats and let it charge before adding it to the compost? Is that what you said?
No, you can incorporate the charcoal into the oat mixture at the initial mixing. So then you have charged the biochar simultaneously and then also made like a super good, like awesome, like, you know, it takes the bokashi making to the next level. There's all sorts of amendments you can add. You can add almost anything to a bokashi compost sort of system. And it's just a really super quick way of, you know, instead of it being like a 6-week hot compost, you can make a 2-week fermented compost way faster.
Cool.
Yeah. Okay, I'm going to touch also on the bokashi bucket system because I only got a few minutes left, I think. But what
Yeah,
people,
3 official minutes. If you feel compelled to share other tidbits, we have 15 minutes to the next session. That
yeah, I can go for a little longer.
Okay.
So what people do is they'll get these buckets, and the bucket will have a little spigot at the bottom so you can drain the liquids out. But they'll take all their household waste and you know, add a little bit of bokashi bran straight at the bottom of the bucket, and then they'll add their kitchen waste a few inches, and then another sprinkling of bokashi bran, and then, you know, kitchen waste until the bucket is sealed, and then they'll let it while they're collecting you know, their kitchen waste. There's the tap at the bottom of the bucket so you can drain off these what's called a bokashi leachate. So you can get a little garden tea every day out of your bokashi bucket, so there doesn't get to be a putrid anaerobic layer at the bottom. Even though the facultative of the anaerobes are supposed to dominate, you know, there's the spigot to just drain the juices every day. And then at the end, when your bucket is full, you set it aside for 2 weeks until it blooms a nice fuzzy white mold. And then you can go bury this pre-digested compost bucket. Like, you can just dig a trench and bury it in your garden, and it'll disappear within a week because everything's already been pre-digested and then ready to be consumed by the soil. And so yeah, that if you look into the Bokashi bucket composting system, that is very interesting. One thing I do is I don't use the brands or anything, but I oil pull, and then when I spit into my bucket, I'm always seeing nice fuzzy white mold, so that's fun. Yep. Bokashi brand bottom, kitchen waste. Yep. Drain is bottom for the leach. Yep, you got it. So okay, I'm gonna now just talk about some of what are cool big scientific words I learned in this last year.
Thank you.
One is rhizophagy. Rhizophagy means root eating. And so how this all ties together is that in the last couple years, there's this guy, James White, I think he's at Rutgers University or something, but he's on John Kemp's podcast and laid down some really cool information. I just watched a really cool Zoom webinar with this guy because he had all these pictures of like the microscopic level where the plant roots bond with the mycelium and then create highways for the bacteria, because the bacteria can't move so much or so fast, and then the mycelium aren't really moving, but they're growing. So then the fungal networks provide highway for the bacteria to make it to the plant roots. But then because we got two different types of symbiotes at the roots, we got endophytes and ectophytes. So we got things we can visibly see like on the surface, like how like chanterelles bond with Douglas fir in a mycorrhizal relationship. So you would visibly be able to see the ectophyte mycelium, but you can't see the endophyte mycelium because that is actually intracellular. It's between the cell walls. And so rhizophagy is when all these sort of endophytes are going on these fungal networks and all these bacteria swim into the openings at the plant roots, and then the plant swallows them and it poops out about 10% of them alive back to go respore and mine more minerals. And so rhizophagy is the word that humans came up with to describe how is it there is a nutrient delivery system of microbes into the roots. How is it that the microbes are liberating these minerals, changing the ionic form so it's actually bioavailable, and then get swallowed up by the roots, and then 10% gets pooped back out to go fulfill its life cycle again. So that word is rhizophagy. It's really cool. I made a really cool slideshow that's on my website. It's on a Google Doc form, but it's on the front page. And I gave rhizophagy like a whole page because it's such a good concept. And then the other concept is redox. And John Kemp on this podcast gets some heady scientist guys to talk about this, but redox stands for reduction oxidation. So when we talk about like EM1 having antioxidant properties, that's because it's not an oxidizing thing like steel turning into rust. It's anti-oxidizing. So then that means it's doing instead redox, which is reducing of electrons. And so that's when redox is when something is actually like gaining electrons from something else, versus oxidation is when it's giving off electrons. So all these microbes are releasing all sorts of enzymes, all sorts of acids, and that is being able to use like the principle of redox to change the ionic constituency, negative or positive, of all these things like phosphorus and silica and nitrogen in the soil. So yeah, those are two of my favorite big words this year, is rhizophagy and then redox. And so what, like that's kind of like, that's like the basis of all this micro mineral mulch magic, you know, all this, why are we applying all these minerals? It's like we're giving the plants kind of an all you can eat buffet of symbiotes to choose from. The plant ultimately chooses who it makes symbiotic relationships with. That is all tailored through the root exudates. The root exudates is a language. So at different times of year, the microbes are tailoring what it's leaking out. I mean, of course, there's probably not too much root exudates being pumped into wintertime soils, but then in the springtime when the light picks up, that's when a plant is going to probably be like trying to make its associations with a lot of like nitrogen fixing bacteria or whatever, the ones that have been liberating things out of the soil that then they need for their springtime growth. And then by the time, if you were to do like soil samples from underneath tree roots in spring versus fall, you would see totally different microbes.
I think this is an awesome reason of why it's good to plant seeds so that they can have the appropriate microorganisms to grow well, or to plant things in the fall if it's an established plant. Then your plant can have time to build that relationship within the soil in its root system before it needs to do a bunch of growth in the spring. So planting early gives it that time. Thank you for the affirmation, other people.
Well, and we're also realizing like some of the healthiest seeds will be like saved in the shell, and that so many of these commercial seed companies, they're spraying so much fungicides on their plants, or I mean, on the seeds themselves, I mean, that then what you end up happening is you have a loss of epigenetic diversity being passed on. You're like basically growing something sterile. And just as we're coming out of you know, the birth canal and suckling on our mother's breast, like, and getting all this inherited microbiome, plants are doing that the same way when they're out like rotting in nature, you know, and so some things need fire, some things need like a bird's stomach, but in so many ways the microbiome is inherited. And so we're seeing so much like devolution in our genetic diversity at this age because of basically, yeah, this loss of epigenetic transfer. And with epigenetics, we are able, it's like we're, as humans, reproduce like, you know, what, like maybe at first, like we're able to reproduce 12 to 15 years old, but most people don't in modern era do it till, you know, 30 or sometimes 40. And then what, like we're slowing down, getting older, but then how are we evolving? You know, things evolve fast when they reproduce fast. Lactic acid bacteria reproduce every 22 minutes. Yeast reproduces every 100 minutes. But when we're you know, kind of causing this schism in the inheritance of valuable information, which is the microbial information we're meant to inherit, the epigenetic is the missing link in our mutation. Like, just as there's like viruses do horizontal gene transfer, and like we get like genes like passed along through both microbes and viruses being shared, we're seeing like this total loss of this like microbiome in humanity. Like even just before we get into the chemical sprayed on our food, just then the food itself being so different than the fiber-rich food of our ancestors. So then our gut microbes are weaker. We're all more like susceptible to all these diseases. It's just like, I like talk about like trying to get it back to the Neanderthal level. You know, it's like, so, okay, fucking Roundup. Roundup is supposed to now actually be partially being blamed for the rise in all the joint infertility, like all the people like feeling like weak kneed and stuff, like more easily broken bones, because we're not as nutrient dense as our ancestors. So we have to grow nutrient dense food so then we can and get this epigenetic sort of microbiome like able to allow us to mutate faster, like, you know, thing going on, and get the food back in our system. So it's like we don't just like have all the rotting teeth, like what Weston A. Price talked about, you know, what Albrecht talked about, what Julius, I think it's Julius Hensel, yeah, this guy wrote Bread from Stones, and he's actually described as a natural farmer in the English translation, even though he was writing in like the 1890s about rock dust. And so that's one last thing I'd also like to talk about, is that you can do all this compost tea, you can do all this sort of bokashi, and you might run into tons of issues. Like I had one of my best years in my orchard and garden because I applied lots of rock dust this year too, because the bokashi is like a soil food web accelerant. And so we're in Western Washington have generally such mineral deficient soils, even though it's better than lots of other places. We, through the logging era and all this modern era, we caused so much erosion and compaction that our soils are notoriously clay heavy. I bet they are not clay heavy soils like they are now, like 300 years ago, because we stripped so much of the humus layer off the soil, you know, surface. We got these really heavy clay soils. So we need like, generally the recommendation is a ton of gypsum or lime per acre. And so whether you're using crushed seashells or whatever, we need to get lots of calcium back into our soils and where it's very clay, because then that fluffs it up, and magnesium overload is why you have clay. And so once you get the calcium ratios back up, you can get that fluffy, loamy soil. I guess if you have really sandy soil, you probably need more magnesium, but I'm dealing with really clay heavy soils. And I've really found that even though all the mulching and the minerals or the microbes were doing things, the minerals is really an important key. And fire ash is a great amendment. You can apply fire ash, 10 pounds per 100 square feet. I've definitely mixed fire ash and minerals and seaweed into my aerobic bokashi piles. Epigenetics, okay, just we have genetics. So epigenetics is a term that applies to how our gene markers get turned on and off. So if you have a bunch of trauma happen, that can be passed down intergenerationally. And so if you eat like and get a bunch of abundance, the next generation will be healthier. So epigenetics is how genes get turned on or off depending on life experience. And so what we're doing with all this natural farming is trying to like epigenetically supercharge a generation or many generations to come, you know?
Yeah, the last few are questions about bacteria and fungi and COVID and how our biome plays into that.
There's a good study. If you go to Cascadian Natural Farming Facebook, I linked a really good study that is an analysis of fermentation in cultures and their diets with lots of specifically like sauerkraut and kimchi and death rate and mortality. So really, yeah, that's part of epigenetics, you know, that's like both boosting your microbiome and giving you a food that's more nutrient available. Virus get eaten by bacteria. Fungi eat the bacteria, then protozoa eat the fungi. Viruses also eat bacteria, and I guess viruses are one of the single most integral parts of like the whole ecosystem of the world, because without viruses eating the bacteria, we would just be like a giant sticky ball of bacterial goo over the whole planet. So viruses are very important in the ecosystem. Slack, maybe, sure. I don't know. I try. There's already so many things I have to talk to people on. You have my phone number though, Julie. You can just call me too sometime. Fungi and mushrooms. Oh yeah, totally. Because that's the thing. Is like even if you're just applying like a bacterial like liquid brew sort of compost tea to soil, you actually create lots of food for the native fungi. So because the fungi eat the bacteria. So like John Kemp, I've mentioned this guy again, but he disagrees with Elaine Ingham on the fungal soil, you know, fungal bacterial ratios you want and why you want a fungally dominated compost tea brew. He says it doesn't matter if you have a fungally dominated compost tea brew because you water in bacteria, it feeds the fungi. So yeah, I think I'm probably gonna go off now and eat some breakfast and stuff, but nice talking with everyone. I hope you all had a fantastic time, and thank you very much, Shaylee and Julie, for hosting and organizing. That's been wonderful.
Yeah, so grateful for you joining us and sharing your wealth of knowledge. It's so fun to hear what you have to share and very encouraging. Super glad.
I can't wait to know as much as you.
Thank you, Peter. I'm definitely a fan. I got one quick joke for you before you leave.
Okay.
What do you call a female mushroom?
Fungal?
A fungal, yes.
Well, mulch love. Nice to see you later.
Nice to see you later.
Love that mulch love. Okay.